So today we're going to be discussing the chapter called as Polynomials from Additional Mathematics. So what is a polynomial function? It is a function that involves only non-negative integer powers or only positive integer exponents of a variable in an equation. So let's look at a few examples. So the first one is linear, meaning the highest degree or the highest power of any variable is 1. So in this example, it is ax plus b, which is a linear function, because the highest degree over here of the exponent is 1. So therefore it's a linear function, where a and b are constants and a is not equal to 0. So let us graph any linear function. So let's take 3x plus 4. So this is a linear function, and the gradient throughout the whole function would be the same. So it's a straight line curve, straight line graph with gradient 3 and y-intercept 4. So the next type is a quadratic function. We've learned that in the previous chapter what a quadratic equation slash function is. So here it's anything in the form of ax squared plus bx plus c. So let us graph this also. Let's take 2x squared plus 4x plus 2. Okay, so we know that it's an upward facing graph because the value of a is greater than 0. So the gradient keeps changing, as you can see, and there's always a turning point for a quadratic function. Okay, moving on. So we're going to be working on the addition and subtraction of polynomials. In order to add or subtract two polynomials, we must collect the like terms. So like terms are terms for the same power to its variable. So over here we can add these two because the power to which the variable is raised to is the same. In both the cases, it's 1 and 1. So we can add the constants. So 2x plus 4x will give us 6x. So we could also add 2x squared plus 4x squared, which would give us 6x squared. And then we cannot add 2x squared plus 4x to the power 5 because they're not like terms. They don't have the same power on the variable. So, and the same rule applies to subtraction. So we could do 2x minus 4x, which would give us minus 2x, because 2 minus 4 is minus 2. And then let's try out an example. So we have to find p of x plus q of x. So we know that p of x is this and q of x is this. So let's add them. So 3x cubed minus 2x squared plus 4x minus 3 plus 6 x to the power of 6 minus 6x cubed plus 7x minus 10. So this is not a like term, so we can just retain it. So this is 1 and minus 6, so that would give us minus 5x to the power of 3. And then this is the only x square term, so you can write this. And then 4 plus 7 would give us 11x. Then minus 3 minus 10 would give us minus 13. And you could do the same for p of x minus q of x. Okay, so let me just work this out. So p of x is x to the power of 3 minus 2x squared plus 4x minus 3, and then minus of x to the power of 6 minus 6x squared plus 7x minus 10. So this would give us the following. So this would be our answer for p of x minus q of x. Okay, so let us do the multiplication of polynomials. There are two types. Scalar multiplication, wherein you multiply a function by a constant. So in order to multiply a polynomial by a scalar, which is also known as a constant, we multiply each term by the scalar value. So let's take this example. So it's 3 into p of x. So then the p of x would be this. And so 3 into x to the power of 3 would give us 3x cubed. Then minus 2 into 3 would be minus 6. 3 into 4 is 12. 3 into minus 3 would be minus 9. So that was scalar multiplication. Now let us look at polynomial multiplication. So in order to multiply two polynomials, we multiply each term of the first polynomial by each term of the second polynomial and collect the like terms. So this into this, and so on. So let me work that out. So we have to multiply the first by the first, and then this into this. So let's solve that. So x to the power of 3 multiplied by 4x would give us 4x to the power of 4, and then negative 3x to the power of 3, and then this into this and this into this. So this would give us minus 8x squared plus 6x. Then the final term, that's 12x minus 9. Okay, so now let's collect the like terms. That is our final answer, which is the answer. So moving on. So now we're going to look at the division of polynomials. So if p of x is divided by ax plus b until a constant remainder r is obtained, then p of x divided by ax plus b equals q of x plus r divided by ax plus b. So here we would call ax plus b as the divisor, meaning it divides something. Then q of x would be the quotient, meaning the result we'd get, and r is the remainder. So if you cross multiply this side by ax plus b, we'd get q of x into ax plus b and then plus r, because ax plus b divided by ax plus b is 1. We'd be left with an r. Okay, so you can notice that the polynomial is basically the quotient into the divisor plus the remainder. Okay, so if that is clear, let's move on to the question. And we'll see how to actually solve such a question. So this method is called as the long division. So you usually write the divisor over here and then write this weird thing, and then write the polynomial inside. And then close this. Okay, so over here, we'd get the value of the quotient. So here, the first term would be x squared. So when we multiply this into this, we're supposed to get the first term of the polynomial. So when we multiply x squared with x, we get x cubed. And then we get x squared minus 3. So we can see that this term and this term are not the same, but we just have to make sure the first term is the same, and we'll handle that later. And now we're supposed to subtract this, whatever we've got here, with the polynomial. So we'd get 0. So minus 1 plus 3 would give us plus 2x squared. And let's bring this term down, the third term. And then we have to keep repeating the process. So when we multiply this term with this term, we get 2x squared. And then 2x into minus 3 would give us minus 6. So let's subtract this. So this will be minus 3x plus 6x would give us 3x. And then let's bring the 5 down. And then if we write plus 3, we'd get 3x minus 9. When we subtract this, we get plus 4. So in this scenario, this is the divisor, this is the polynomial or p of x, this is the quotient, and this is the remainder. This may seem confusing, but after a few examples, it will be much more clear. So let's write p of x in this form. So q of x, which is basically the quotient, is x squared plus 2x plus 3 into x minus 3 plus the remainder. So this is our final answer, which is also equivalent to p of x, which is our function. Let us work on a few examples to ensure that this concept is very clear, because it's going to come very frequently, not only in additional mathematics, but in also AS level and A level if you decide to take it. So let's work on a few examples. Let's start with this one. Okay, so like always, we'll write the divisor over here, write the symbol, put the polynomial inside, and close it. So what multiplied by x would give us 2x squared? It's 2x, right? So we write that over here. And then we'd get 2x squared. And when we multiply this by this, we get minus 4x. Let's subtract this. We'd get minus 3x. Let's bring this down. And now it's going to be minus 3. So minus 3x plus 6. When we subtract this, we get minus 4. So therefore, the divisor is this. The quotient is 2x plus minus 3, and the remainder is minus 4. When we put this in the proper form, we get x minus 2 multiplied by 2x minus 3 minus 4. So let us just multiply this and simplify this whole thing to ensure that this is equal to the polynomial. So this would be 2x squared minus 3x minus 4x plus 6 minus 2 minus 4. So this is 2x squared minus 7x plus 2, which is indeed the polynomial. Okay, so let's work on this example. Try this out with me and I will reveal the answer. This is our final answer. Let's work out the last problem. So this is our final answer. All right, moving on. Let us try some harder examples to ensure that we know this concept really, really well. So this is our question. Like always, we read the divisor over here, enclosed by this symbol. With the polynomial inside, which is also known as the dividend. And then we have to find the quotient here. So the quotient would be 1, because 1 times x squared would give us x squared. So we write this down and then we subtract this. It's not necessary that we always get a constant as the remainder. We can always get functions of degree 1, degree 2, anything. So let's write this in the proper form. So this would be 1 times x squared plus x plus 1 minus 2x. So this would give us the dividend, also known as the polynomial. Now let's do the next example. Okay, so first let us expand x minus 1 whole squared, which is x squared minus 2x plus 1. So divisor here enclosed by the symbol with the dividend inside and close it. So it will be 2x now let's subtract. the polynomial is divisor into quotient plus the remainder. So this is our polynomial. Let's solve the last question. You know the drill, so let's just do this. Alright, so this is our procedure. So x to the power of 4 plus 3x squared plus x minus 1 is essentially the dividend into the quotient plus the remainder. So this is the last problem on long division and the division of polynomials. The next subtopic is zeros, roots, and factors. So a zero of a polynomial is the value of the variable which makes the polynomial equal to 0. So in the previous slides we discussed about what a polynomial is. So a zero would be a value that would make the polynomial equal to 0. So if alpha, which is a Greek symbol, is a zero of the polynomial, then p of x, this implies that p alpha equals 0. So this is obvious because we usually equate a polynomial to 0 in order to find the solution or the 0 of the polynomial. So if you substitute the value of alpha into p of x, then you'd get 0 because alpha is the 0 of a polynomial. So the next is the roots of a polynomial equation are the solutions to the equation. So this is very similar to the previous one, except a 0 is related to a polynomial and a root is related to an equation. Both of them are the same concepts, but we usually call the solutions of an equation as roots and the solutions of a polynomial as a 0. So similarly, if alpha is the root or the solution, then p alpha equals 0. And yeah, so the roots of p of x equals to 0 are the roots of p of x and the x-intercepts of the graph of y equals p of x. So basically the value of y becomes 0, right, when we try to find the solution. So essentially what we're trying to do is making the value of y equal to 0, meaning that we get certain values of x. So therefore we get the x-intercepts of the graph as the solutions or the roots of the equation. The next point states that x minus alpha is a factor of p of x. So if that is true, then there exists a polynomial q of x such that p of x equals x minus alpha times q of x. So that's pretty simple. So let's move on. Let's try to solve some questions. based on zeros, roots, and factors. We've already done this in the quadratics chapter, so this is just going to be extra practice. So over here, we have a quadratic function. We could use the formula x equals to minus b plus or minus square root of b squared minus 4ac whole divided by 2a to solve the question. So minus b would be 5. So plus or minus 5 squared is 25. Minus 4 into 2 into negative 12 divided by 4. So this is going to be 5 plus or minus 25 plus, this is 48 into 2 would be 96 divided by 4. And now using the calculator, I'm just going to find this. So this is 5 plus or minus square root of 121 divided by 4. And square root of 121 is 11. So we can write that. Therefore, the solutions or the roots of the equation are minus 3 by 2 and 4. So these are the solutions of this equation. So now let's equate this to 0 and solve it. We're trying to find the roots. So we can take x as common. So x times x minus 2 minus 4. So we can use the formula a squared minus b squared equals this would be x multiplied by x plus 2 times x minus 2 equals to 0. So x equals 0, x equals minus 2, or x equals 2. So that's our solution for this question. And then so this is our next question. So we're supposed to find the roots of the equation. So first we'll equate this to 0. We get x equals 1 by 3. We got to equate this to 0. So let's do that. By splitting the middle term, we get x plus 3 times x minus 2 giving 0. So x equals x plus 3 equals 0, implying that x equals 3, or x minus 2 equals 0, implying that x equals 2. So therefore x equals 1 by 3, x equals minus 3, and x equals 2. Okay, moving on, let's solve this question, this one. So let's rearrange this. And now let's use the quadratic formula. Or we could just use the splitting the middle term because that's easier. So we'll plug this back into the equation to see whether we're right. So 5 into 1 squared minus 3 into 1 minus 2 equals what? So this would be 5 minus 3 minus 2, which is 0. So this is right. Now let's put minus 2 by 5 into the equation. So which is indeed 0. So the solutions are right. And now let's equate this to 0. Let the equation be this equals to 0. So in this case, you cannot directly solve it. We have to make a substitution. So let x squared equal to z. This is done to make sure that we get a quadratic equation instead of the one with a degree 4. So let's do that. So this would be z squared minus 6z plus 8. Over here we can split the middle term into -2 and -4. On multiplication we get 8. So we can use this. So we get z squared minus 2z minus 4z plus 8 equals 0. And then we can factorize it. You may think that we're done right now, but that's not the case. We have to find it in terms of x because our original equation, this equation, was in terms of x. So we know that z equals x squared. So upon substitution, we get this. So x equals plus or minus square root of 2, or x squared equals 4. That means x equals plus or minus square root of 4, which is 2. So plus or minus 2. So the roots are root 2, minus root 2, 2, and minus 2. These are our roots to our equation x to the power of 4 minus 6x squared plus 8 equals 0. So now that we've solved all these 5 questions, I hope it's clear. Yeah, moving on. Let's talk about polynomial equity. So when two polynomials are equal, if and only if they have the same degree, which is the exponent on the variable, and the corresponding terms have equal coefficients. So this is the polynomial equity rule or a statement. So now let's look at this example. So we have to find constants a, b, and c given that this statement is true for all values of x. So what you have to learn from this is that if the variable has the same exponent and there is an equal to symbol in between, you can basically, when you simplify this, whatever coefficient is next to the x cubed term, you can equate it according to this rule. Let's look at the worked example to ensure that this concept is quite clear. So we have this statement. So find constants a, b, and c given that this polynomial is equals to this for all values of x. So our first step would be to expand this. So upon expanding, we get a polynomial stated below. So yeah, and then we have to simplify it. We have to basically add like terms together and subtract like terms to ensure that it's simplified and it's in decreasing order of the variables on the exponent. So now we have this statement. So now we have 6x cubed equals to this. For now, we'll just consider this. So therefore, we can equate these two because they have the same degree. So upon equating, we get a equals 3. And then what we can do next is find the value of c, because it doesn't have any other variable related to it, in the sense it doesn't have multiple variables to solve for. So we first find the value of c, which is -7, and then we can equate 2b minus a to 7, and we already have the value of a, so we can substitute that. So it would be 2a minus 3 equals 7. So it would be 2b equals 10 and b would be 5. So you can also check in this and you'll still get 5. So that would be minus 19 equals 2c minus b. C is -7, so we can write -14 minus b equals -19. When we put this to the other side and take b to the other side, we get b equals 5. So we get b equals 5 in both equations, implying that we are indeed right. So we can finally state that a equals 3, b equals 5, and c equals 7. If polynomial equity is clear, then let's move on to the next topic, which is the remainder theorem. So this is extremely important in additional mathematics because I can tell you for sure that at least one question, which is basically question 1 or question 2, is going to be based on the remainder theorem and the factor theorem. So it's very essential that you know this. So yeah, let's get into it. So when a polynomial p of x is divided by x minus k until a remainder r is obtained, then r equals p of k. So that's our statement. So x minus k is the divisor. The dividend is p of x, and the r is the remainder. So if you put k into the function or the polynomial, you will get the remainder. This may seem confusing, but let's prove it. So when we divide a long division or like a polynomial by a certain divisor, which is x minus k in this case, this is what we get, right? P of x equals q of x, which is the quotient, multiplied by k minus x plus r. So now it states that r equals p of k, right? So if we put the value of k into the equation, we get p of k equals q of k into k minus k. It doesn't matter what value of quotient we get, but we just need to notice that this becomes 0. So when this becomes 0, this whole term becomes 0 because anything into a 0 is a 0. So we are left with the remainder. So that's how we prove this, and that's how we know that this statement is indeed true. So now let's just look at this also. So if p of x equals x minus k into q of x plus r, we get p of k equals to r. So if p of x is divided by x minus k, it leaves a remainder of r. So the takeaway from this slide would be that if a polynomial is divided by x minus k, but k is a constant, then the remainder would be p of k. So if that's clear, let's move on to the questions. So the divisor is x minus 1, which is in the form x minus k, implies that k equals 1. So in order to find the remainder, we need to find f of 1, let this be f of x, equals this. So r would be f of 1. So let's substitute the value of 1 into the polynomial given. So it would be 1 cubed plus 2 into 1 squared minus 7 into 1 plus 8. We get 1 plus 2 minus 7 plus 8. We get, when we add this and this, so this would be 3 minus 7 plus 8. 3 plus 8 would be 11 minus 7 equals 4. So the remainder would be 4. Okay, so let us actually do the long division to ensure that it is the statement that we have gotten, the statement is actually true. So let's do this. You know the drill. Divisor, I will do it in a different color. So the divisor on one end, the symbol with the polynomial inside, minus 7x plus 8, close it, and now we write x squared here, so this would be x cubed minus x squared. Let's subtract this. This would give us 3x squared. Let's bring down the 7x. So this is going to be plus 3x. So 3x squared minus 3x. Let's subtract this. We get minus 4x. Bring down the 8. This would be minus 4. So minus 4x plus 4. When we subtract this, we get 4. So the remainder is indeed 4. And that's what we got here also. Moving on. So let's look at this question. So when this polynomial is divided by x minus 2, the remainder is 7. So let's write down the information we know. So let's define the function f of x as x cubed minus 2x plus a. So here we're supposed to find the value of a. So this is our question, and the divisor would be x minus 2 and remainder is 7. So we know that if the divisor is x minus k, then f of k equals r. So let's write x minus 2 comma f of 2 would equal r, implies that f of 2 equals 7. So let's substitute this. Okay, so we get the value of a equals 3. So let's use long division to actually prove that the remainder is indeed 7 by substituting the value of a into the equation. So the divisor on the left hand side and the polynomial inside. So over here it would be x squared. So x cubed minus 2x squared. Let's subtract this. It's going to be 2x squared. Bring down the 2x minus 2x, so it's going to be plus 2x. So 2x squared minus 4x. On subtracting this, we get 2x, bring down the 3, it's going to be plus 2. So 2x minus 4, when we subtract this, we get 7, which is the remainder. So we are indeed right. Moving on, let's move on to this question. let's choose a nice color, this blue. So yeah, so here you can see that this is not in the form of x minus k. It's rather in the form of ax minus b. So it looks confusing, that's true. But then let's just break this down from scratch and see what we'll actually have to do. So we know that p of x equals q of x into the divisor. Divisor, I'm not going to write anything, I'm just going to write b of x plus r. So in this case, let's substitute the divisor as ax minus b. So q of x into ax minus b plus r. So we have to make this term 0. So we can write q of x into a minus b equals to 0. So this the quotient, we're not 100% sure that it's going to be 0. In most cases, it's never going to be 0. So we are supposed to make this 0. So ax minus b equals 0. So when upon rearranging, we get ax equals b and x equals b by a. So we get p of b by a equals q of x into a into b by a minus b plus r. This would give us q of x, this gets cancelled, so b minus b plus r. So we get q of x into 0 plus r, which is r. So we do get the remainder. So when it's in the form of ax minus b, you have to use the formula p of b by a. So yeah. So now let's solve this question. So let's read the question. So we have to find the remainder when the polynomial 4x squared minus 10x plus 1 is divided by 2x minus 1. Okay, so here the divisor is 2x minus 1. When we equate this to 0, we get x equals 1 by 2. So we have to write p of x equals 4x squared minus 10x plus 1. We write p of 1 by 2 equals 4 into 1 divided by 2 whole squared minus 10 into 1 divided by 2 plus 1. We get 4 into 1 by 4 minus 5 plus 1. This is 1 minus 5 plus 1. So it's 2 minus 5, which is minus 3. So the remainder is minus 3. Now let's do long division to find the remainder. Okay, so the divisor on one end, the polynomial within, which is 4x squared minus 10x plus 1. Then we write the quotient here, so it's going to be 2x because 2x into 2x gives us 4x squared. So 4x squared minus 2x, and then so minus 10 plus 2 would be minus 8x. Bring down the 1, we write minus 4, so minus 8x plus 4. Upon subtraction, we get minus 3, which was also our previous answer. So now let's solve this lengthy problem. So let's define p of x as x cubed plus 2x squared plus ax plus b. So it's given that when the polynomial is divided by x minus 1, the remainder is 4. So it implies that p of 1 equals 4. So therefore 1 cubed plus 2 into 1 squared plus a plus b equals 4. So we get 1 plus 2 plus a plus b equals 4. So a plus b equals 1. So let's write this in terms of b. So b would be 1 minus a. Let's name this as equation 1. The second condition is that when the polynomial is divided by x plus 2, the remainder is 16. So that means p of minus 2 equals 16. Let's substitute the values in. Negative 2a plus 1 minus a, because of this, get 16. So minus 3a equals 15 implies that a equals negative 5 and b equals 1 minus a, so equals 1 minus of minus 5, that is 6. Therefore a equals minus 5 and b equals 6. So this is our final answer. So now let's actually divide the polynomial by the two divisors to make sure that we got the right values of a and b. So let's do that. Okay, so let's first divide by x minus 1 and put this in. A was minus 5, b was plus 6, and let's find this now. So it would be x squared, so which is indeed the thing that they had given. So we got the right value of a and b. Okay, so let's divide by x plus 2 to also confirm that the remainder is 16. So let's do that. This is just to confirm again. So let's do that. This is just simple long division. So x squared, so x cubed plus 2x squared. So this whole thing cancels out. We are left with minus 5x plus 6. So minus 5 would be minus 5x minus 10. When we subtract this, we get 16. So that was what was given. So this further confirms that the value of a and b that we got was true. Now let's look at the next topic in polynomials. So this is the factor theorem. It's somewhat related to the remainder theorem. So let's look at what it is actually. So for any polynomial p of x, if k is a 0 of p of x, that implies that x minus k is a factor of p of x. We already know that. So, but the factor theorem comes into the picture when we are trying to figure out whether a polynomial has a factor. So we can figure that out without having to do the long division method. Or so what you do is you do the same thing as the remainder theorem, except if you get a value of 0, which is the remainder, it means that it is a factor. So like that's what factor remainder theorem essentially is. So if k is a 0 of the polynomial, then p of k will be 0, meaning that the remainder will be 0 and p of x will just be this. And essentially it shows that x minus k is a factor of p of x. Now let's look at a worked example to see how it really plays. So if 2x minus 1 is a factor of this, and the remainder when f of x is divided by x minus 1 is minus 1, find the values of a and b. So without looking at the solution, we'll just look at the question first and we'll see what we're supposed to do. Since this is a factor, that means p of 1 by 2, or in this case f of 1 by 2 will be 0, since the remainder must be 0, and that's what they have done. And then you like substitute the values, and then you just find a simplified equation in terms of a and b. So that's going to be our first. I would have just written b equals 1 by 2 minus 1 by 2a. So, and then next it states that when it's divided by x minus 1, the remainder is minus 1. So that means f of 1 will be negative 1. So we form another equation using this statement. So we have two equations right now. So upon solving it simultaneously, we get the value of a and b. So over here, they have multiplied the first equation by 2 to make sure a and the value of a here and the value of a here remain the same, and like the coefficient. So you can like cancel them out, and then they just simplified, and then they get b equals 2. And when you substitute this back into the equation, we get a equals minus 3. So that's how this theorem works. So you can get questions based on the remainder theorem and the factor theorem, or just like remainder theorem or just factor theorem. So now that we have understood what the remainder theorem is, and we have looked at the sort example, now let us actually go on to solving them. Take a few minutes to solve this. For these two questions, let's determine whether, and then the thing. So take a few minutes to solve it, then I will solve it after you're finished. So just unpause the video after you're done. And yeah, okay. So now let's go on to the problem. So let's start. Okay, so we have to determine whether x minus 1 is a factor of 4x cubed minus 7x squared plus 5x minus 2. So how do we do that? We use the factor theorem. So if p of 1 equals 0, that means this is a factor of this. So let's do that. Let f of x equal 4x cubed minus 7x squared plus 5x minus 2. So if f of 1 equals 0, that means it is indeed a factor. So This is going to be 4 minus 7 plus 5 minus 2. This is going to be 9 minus 9. So 4 plus 5, 9, minus 7 minus 2 minus 9. So this is 0. So it is a factor. Now let's move on to this question. So we'll see if this is a factor. So let p of x equal 3x cubed plus 5x squared minus 6x minus 8. So p of minus 2 equals 3 into negative 8 plus 5 into 4 plus 12 minus 8. So this is negative 24. This is plus 20 plus 4. So that's negative 24 plus 24. That is 0. So this is also a factor. So x plus 2 is also a factor of the polynomial. Let's move on to the next question. So it's this. Let's take a minute to read it. So find C given that x plus 1 is a factor of this polynomial. So let's say g of x equals 5x cubed minus 3x squared plus cx plus 10. So it's given that this is a factor. So g of minus 1 equals 0. So 5 into negative 1, negative 3, negative c plus 10 equals 0. So negative 5, negative 3 plus 10 equals c. So c equals 10 minus 8, which is 2. So now let's plug this back into the equation. So this is our equation, our polynomial, and let's actually do the long division to make sure that we got the right answer. So the divisor here, the polynomial inside, okay, and now let's do the long division. Since the remainder is 0, we got the right answer for the value of c. So this is how you do it. So let's solve the last question. So let's read the question. X plus 2 is a factor of p of x, which is 2x cubed plus x squared plus kx minus 4. So we have to find the value of k, and then we have to write p of x as a product of linear functions. So let's do that. Okay, so we know that p of minus 2 will be 0. So into minus 8 plus 4 negative 2k minus 4 equals 0. 16, 4 and 4 get cancelled, so 2k equals negative 16 and k equals negative 8. So and now p of x equals 2x cubed plus x squared negative 8k minus 4. Now let's do the long division to write this as a product of linear factors. So let's divide this by x plus 2. So therefore p of x equals x plus 2 into 2x squared minus 3x minus 2. We can split the middle term and write this. So this is our final answer. We have written this in the form of linear products. So that's all for this chapter. So the chapter polynomials is done, and hopefully it was helpful. And stay tuned for the next chapter, which is gonna come out in a couple of days.